Good evening, everyone. I'm Kia Hasini from Group 330, and I'm excited to walk you through joyVerse, a real-time emotional intelligence platform designed for dyslexic children. It integrates playful learning with AI-driven emotional feedback. Let us dive into this project. Coming to the major learning slide, through this project, I gained hands-on experience in building a multi-layered system. The front end is React, and the middleware is Express.js, and the machine learning backend is built in Python using Flask. I learned how to stream video data in real time, how to turn machine learning model into an API, and how to manage a critical state and to ensure a smooth and consistent user experience, especially for children who are struggling with dyslexia. Now, let us discuss about a few important key code snippets from the project. The first one is the front end sending the game events to the back end. This code listens to the game process like when a level starts or ends and sends the data to the server using fetch or post request. This allows the backend to record player progress and trigger adaptive gameplay. And the second one is the front end sending face landmarks to the Express.js. Here, we are using face tracking model which we have built through face mesh. These detect key points on the face like eyes, eyebrows, or lips. The front end extracts this data and sends it to the Express.js server. This is lighter and more efficient than sending the entire video to the backend. Now, let us discuss about the key snippets from the backend part. The first one would be the model wrapped in Flask API. We have built a transformer model in Python to detect emotions from the facial landmark data. This model is exposed as an API using Flask. So when the server receives the face landmarks, it just calls the model and gets the predicted emotion. And the second one is the sending landmarks to the front end. After processing the data and predicting the emotion, the result is sent back to the front end. Based on that, the game can adapt and change its emotions. For example, if a child looks confused, the game might slow down or offer easier words. It's like using a smart assistant. The front end says, here's what the child face is doing. And then the back end replies like, it looks like they are frustrated. And then the game changes to easier level to help make child feel better. Now, let us discuss about the key changes in this project. Earlier, we were trying to send the raw video, but now we only send the facial landmarks. That makes everything faster because now the flow looks like first the front end captures landmarks and then the Express.js receives them and sends them to the Flask model. And then the model gets the emotions and process it and replies with the predicted emotion, and then the Express logs this into the database and sends the feedback to the game so that it can adapt in the real time. And now we have also introduced a super admin dashboard so that the therapist can control who accesses what, and which is essential for the privacy and safety. Coming to the milestone goals, in the milestone one, we have promised some changes which we would make in the upcoming weeks, and all the features that we have promised are completed. The first one would be the therapist and child authentication. Both are done. The therapist authentication is done via super admin dashboard, and the child is done via therapist dashboard. The game themes and levels are changing dynamically according to the emotions that they have been sent from the backend. And the word search logic is also implemented, which was not implementing properly in the back phases. And the therapist dashboard now includes a report of what the emotions were and the major emotions in the changes, and it also shows the emotional change of the child. And now we have integrated the model successfully to the game. Before, we were using a dumb technical model which generates the emotions randomly, but now we are using our own designed model so that we can get the emotions in real time and the game changes according to that. Coming to the challenges faced, this project wasn't without hurdles. The first and the major one would be the face detection. Coordinating between different models like Face API and Face Mesh was tricky, especially with the camera delays and incorrect emotion recognitions. And the second one would be the adaptive learning, as designing a system that reacts to that reacts in real time to emotions, and performance was complex. And the state management too, like when games needed to resume from where they left off even after refreshes, was hard, and we need to store that in the database too. So getting that thing was hard. And the performance, real-time emotion recognition and game logic can get heavy, so optimizing for speed was beneficial for us. And the error handling, things like camera permission delays or game delays or exiting the games, we were handling this with robust error handling techniques so that it can look cohesive and not unprofessional. Coming to the model selection, this was very important part of the project, as the model is the core part of our project. So we used a transformer model built from scratch, which we have made it ourselves by combining different data sets and different emotions. Because facial landmarks over time form patterns like furrowed brow that becomes frustration. Transformers are great at understanding sequences. This gave us more accuracy and flexibility compared to the off-the-screen models. Uh, Coming to the alternative models we have chosen or selected. We first tried using SVM on the FER 2013 dataset, which is good for basic emotion recognition using still images, but still it didn't work well with the real-time sequential facial data. It couldn't track expressions changing over time. So we have opted for our own built transformer model. Coming to the deployment, right now everything runs on a single server. The Express.js, middleware, Flask model, and the MongoDB database. In future, we'll containerize the system using Docker and move it to the cloud, AWS or Azure. That will make it easier to scale and manage. But right now, we are running all the things in one server. It is our future plan to deploy this project. Now, let us look at a demo video which consists the working prototype of this project. Now let us look into the demo. Starting, this is the front end and how our website looks. And now we are logging into the super admin and dashboard. Using the username and password, we can log into the super admin dashboard. And we can register new therapist and also view the existing therapist. Here is also existing therapist named Hasini. And now we can go to the home page and do other processes. Now, to get the therapist portal, we need to click on Get Started and enter the therapist and password to get to the dashboard. We can also use Add Child, so we can create a new child and assign themes to them. We need to assign 3 themes to them and save the theme assignment so that the kid will get only those themes when he plays. And now we need to log in as the kid to play the game. To do this, we need to click on the get started, and we also need to enter the username given by the therapist and the therapist code to log in. As we log in, we see the instructions to to play the game, and the game is loading right now. So we get the themes and the words. We need to click on the words based on the images given. There are 2 models in our game, like the face mesh and face API. Right now we are playing on the face mesh model. There is also puzzle played into the top left corner. And now we have switched the model from face mesh to face API. Face API also recognizes the landmarks based on our expressions. So here is the continuation of the game. We are right now we are quitting the game, and here is a game ended slide. And now to check we need to check the therapist report on the child's game. So we are logging in as therapist, so we can see their session data. The theme journey shows that the kitchen, how themes and emotions are detected. And here is the emotion distribution pie chart according to those. And here is the how the data is stored in the MongoDB under the therapist section. Like we are having all the objects here. And this is the end of the presentation. Thank you for listening and have a good day.